In this lesson, we're going to be solving word problems involving one variable, and we'll take a look at several different types of word problems together. Let's start with this word problem here. Patty is thinking of two numbers. She says that the first number is 24 less than 4 times the second number, and the sum of the two numbers is 71. What are the two numbers? So the first step when we're solving a word problem is we want to ask ourselves, what are we trying to find? What is the unknown? In this word problem, we're trying to find the two numbers. So the two numbers are our unknowns. So we will use our variable to represent these unknowns. I'm going to call one of the numbers the first number, and I'll call the other number the second number. Now, it might be tempting to use two different variables here. For example, you might be tempted to let x equal the first number and y equal the second number. But in Chapter 1, we have not yet learned how to solve problems involving two variables. Because we haven't learned how to do that yet, we're going to solve all of the problems in Chapter 1 using only one variable. So we want to describe both numbers using only one variable. Let's see how we can do that. To start, let's let x represent the second number. Now, if x represents the second number, let's see if we can describe the first number using x. We see here that it says the first number is 24 less than 4 times the second number. So how could we write 4 times the second number? That would be 4x. Now the first number is 24 less than 4x. So 24 less than 4x would be 4x minus 24. So now we've represented both the first and the second number using only one variable, x in this case. Once you've used a variable to represent your unknowns, the next step is to write an equation. To write our equation, let's take a look at this sentence right here. The sum of the two numbers is 71. So if we take the first number, which is 4x minus 24, and add the second number, which is x, their sum should be 71. Now we've made it through what I think is the hardest part of the problem, just coming up with the equation. Once we've got the equation, then we can go ahead and solve the equation for x. So let's combine these like terms here. 4x plus x will give us 5x. Bring down the minus 24 and the equal 71. Now we want to isolate x. So to isolate x, let's add 24 to both sides. That will leave us with 5x is equal to 95. And the last step of isolating x will be to divide both sides by 5. And that will leave us with x is equal to 19. Now, make sure you don't stop here. With a word problem, you want to make sure you've fully answered the question. The question was, what are the two numbers? We've found x, and let's go back and look at the start of the problem to see what we defined x as. X is the second number. So we can start by saying the second number is 19. Now, how do we find the first number? Well, if we look back up here, we said that the first number is 4x minus 24. We know that x is 19, so let's plug 19 in for x. And if we compute 4 times 19 minus 24, we get 52. So our first number is 52. Let's take a look at the next problem. Okay, let's start by reading through the problem. Max is a savvy 18-year-old. For his graduation, Max's grandparents gave him $10,000. Max decides to invest all of the $10,000. He will put some of the $10,000 into a savings account that pays 2% per year in interest, and the rest into a stock fund that pays 10% interest per year. Max's goal is to gain $700 in interest from his investments after 1 year. How much money should Max put in the savings account, and how much should he put in the stock fund? Now, this is a good example of a word problem that when you read through the first time can be very overwhelming. There's lots of different types of numbers and dollars amount and percentages, but once you work through a problem like this, you'll learn the steps to solve it, and then you can practice similar types of problems, and you'll find that these problems really aren't overly difficult. With a word problem, we always want to start by asking ourselves, what are we trying to find? In other words, what are the unknowns? This will help us to introduce our variable. So what are we trying to find? How much money should Max put in the savings account? And how much should he put in the stock fund? So these are our two unknowns: the amount of money Max should put in the savings account and the amount of money Max should put in the stock fund. Now, again, it's tempting to use two different variables here, maybe X to represent the amount in the savings and Y to represent the amount in the stock fund. You could solve this problem using two different variables, but we haven't yet learned how to do that. So for chapter 1, again, I'm going to recommend that you solve all of the problems using one variable. So let's start by letting X represent either one of these. It doesn't matter, you'll get the correct answer either way. I'm just going to let X equal the amount in the savings account. Now, the next step is to ask ourselves, how can we represent the amount in the stock fund using X? Let's look back at the problem. We see that Max has a total of $10,000 that he's going to invest. I'm just going to pull out a separate sheet of paper to explain this next concept. So we know that Max has a total of $10,000 that he can invest. He's going to put some of the money in a savings account, and he'll put the rest of the money in the stock fund. Now, at this point, we don't know how much he's putting in the savings account and how much he's putting in the stock fund. That's what we're going to have to find out. But let's just pretend that we knew that he was putting, for example, $8,000 in the savings account. How much would he be putting in the stock fund? Well, if he's investing a total of $10,000, if he puts $8,000 in the savings account, how much of the $10,000 would be left over to put in the stock fund? $2,000. Okay, now let's pretend instead that Max invested $4,000 in the savings account. How much of the $10,000 would be left over to invest in the stock fund? $6,000. If Max, for example, invested $3,000 in the savings account, how much of the $10,000 would be left over to invest in the stock fund? $7,000. Now, I just made up these numbers. We don't actually know how much Max is invested in the savings account or in the stock fund. So we said that X represents the amount Max is investing in the savings account. If Max invests X in the savings account, how much is left over for him to invest in the stock fund? Well, let's look back here. When we knew that Max had invested $8,000 in the savings account, to determine how much of the $10,000 was left over to invest in the stock fund, we took $10,000 minus $8,000 to give us $2,000. If Max invested $4,000 in the savings account, how much is left over to invest in the stock fund? We can take $10,000 minus the $4,000 that he's investing in the savings account, and that gives us $6,000 left over for him to invest in the stock fund. Okay, now let's suppose Max is investing X dollars in the savings account. To figure out how much of the $10,000 is left over to invest in the stock fund, we just take the $10,000 minus the X dollars that he's investing in the savings account, and that will give us the leftover that he will invest in the stock fund. So this is what we're going to write on the previous page. If Max has a total of $10,000 to invest, if he invests X dollars in the savings account, to find out how much is left over for him to invest in the stock fund, we would take 10,000 minus X. Now that we've used our variables to represent our unknowns, the next step, and often the most difficult step, is to come up with an equation to represent our situation. We can use the following equation. The total interest is equal to the interest from the savings account plus the interest from the stock fund. Okay, so let's use the information given in the problem to fill in this equation. To start, I'm going to look at the interest percentages that are given. Let's see. The savings account pays 2% interest per year. So I'm just going to put a 2% next to our savings account here, just to organize our information. Then we're told that the stock fund pays 10% interest per year. So I'm going to put a 10% next to our stock fund, just to organize the information. Now, what is the total interest? Now be careful here. $10,000 was the total invested. It was not the total interest. If you keep reading, we see that here it says Max's goal is to gain $700 in interest. So this is the total interest, $700. Now, how do we represent the interest gained from the savings account? To compute the interest gained from the savings account, we just take the interest rate converted to a decimal and multiply by the amount in the savings account. So 2% as a decimal is just 0.02, and then we multiply by the amount, or x in this case. Okay, to represent the interest from the stock fund, we're going to take the interest rate times the amount invested. Interest rate converted to a decimal would be 0.10, multiplied by the amount invested, which is 10,000 minus x. So again, to compute the interest from the savings account, just take the interest rate times the amount invested, x. And then to compute the interest from the stock fund, just take the interest rate times the amount invested, which was 10,000 minus x. Now we've made it through what's the hardest part for most of us, which is writing the equation. Now we go ahead and solve the equation. To solve the equation, let's start by simplifying this right side here. We can start by distributing. Let's see, we'll bring down the 700 and the 0.02x. 0.10 times 10,000 will give us 1,000. And 0.10 times negative x will give us a negative 0.10x. Now let's again bring down the 700, and then we'll continue simplifying this right side of the equation by combining like terms. 0.02x minus 0.10x will give us negative 0.08x, and then we'll bring down the plus 1,000. Now we want to isolate x. We want x all by itself. So to isolate x, let's subtract away this 1,000, and then we'll subtract 1,000 from the other side. That will leave us with negative 300 is equal to negative 0.08x. Now to isolate x, let's divide by negative 0.08, and then we divide this side by negative 0.08. Negative 300 divided by negative 0.08 gives us 3,750 is equal to, these negative 0.08s cancel, and we're just left with x. Now again, with word problems, make sure at the end you've answered the question. The question asked, how much money should Max put in the savings account? Well, let's see. X represents the amount in the savings account. So we've found X. So we can start by saying Max should put $3,750 into the savings account. And then the other part of the question asked, how much should he put in the stock fund? Well, the amount he should put in the stock fund can be found by computing 10,000 minus X. So to compute how much he should put in the stock fund, we can take 10,000 minus X, which would give us 10,000 minus 3,750, which gives us 6,250. Let's take a look at another example. The way we're going to solve this problem is actually very similar to the previous problem. We're just dealing with a different situation. To start, we'll quickly read through the problem. Diana has been saving nickels and dimes. Her piggy bank contains 48 coins that total $4.50. How many nickels and how many dimes are in her piggy bank? So to start, I'm going to underline the unknown, what we are trying to find. We're trying to find how many nickels and how many dimes. So we're going to use a variable here to represent our two unknowns. We'll need to represent the number of nickels, and we need to represent the number of dimes. Now again, in chapter 1, we're going to try to solve these problems using only one variable. So let's let x equal either one of these. It doesn't matter. You will get the correct answer in the end either way. So I'm going to let x represent the number of nickels, but if you prefer, you could let x represent the number of dimes. Now the next step, we want to represent the number of dimes using x. So to start, let's identify how many total coins we have. We can see from the problem that we have 48 total coins. So on a separate sheet of paper here, so we don't know how many nickels we have or how many dimes we have. Let's just pretend that we had 10 nickels. Since we know that we have 48 coins in total, if 10 of those coins are nickels, to figure out how many dimes we have, we could just take 48 minus 10, which would give us 38 dimes. What if, for example, we had 8 nickels? Again, if we take the total number of coins and subtract away the nickels, that will give us how many dimes are left over. 40 in this case. Okay, now I just made these up. We don't actually know how many nickels or dimes we have, but let's suppose we have X nickels. If we have 48 coins and X of those coins are nickels, how many of those coins are dimes? We can use the same idea here. Just take the total number of coins we have, 48, and subtract away however many nickels you have, which is X in this case, and that will leave us with the number of dimes. So now we've represented the number of dimes using X. So let's copy this over to the previous page. Okay, so we just said we can represent the number of dimes as 48 minus X. The next step is we have to come up with the equation. Let's read through the problem and see what piece of information we haven't yet used. Let's see. We haven't yet used the fact that the total value of the coins is $4.50. To calculate the total value of our nickels and dimes, we just need to take the value of our nickels plus the value of our dimes. And this formula can be adjusted depending on what type of problem you're dealing with. Maybe you're dealing with quarters and pennies, or maybe you're dealing with $10 bills and $1 bills, for example. So let's see. We know that our total value is $4.50. And how do we compute the value of our nickels? Well, each nickel is worth 5 cents, which we can write as the decimal 0.05. To find the value of our nickels, we just take 5 cents times the number of nickels. So that would be 0.05 times X. Each dime is worth 10 cents, which can be represented as 0.10. To find the value of the dimes, we just take 10 cents times the number of dimes, or 0.10 times the number of dimes, which is 48 minus X. Now we've come up with the equation. Now we just need to solve the equation. So to start, let's simplify this right side here by distributing this 0.10, and we can bring down the $4.50 and the 0.05x. And if we distribute 0.10 times 48 gives us 4.8, and 0.10 times negative x will give us negative 0.10x. And we'll continue to bring down the 450. And if we combine the like terms here, 0.05x minus 0.10x gives us negative 0.05x. Now we want to isolate x. So to isolate x, let's start by subtracting the 4.8 from the right side, and then we'll also subtract 4.8 from the left side. 4.5 minus 4.8 gives us negative 0.3. And we'll bring down the negative 0.05x. Be careful with the decimal placement here. The most common reason students get these problems wrong is because they'll move the decimal place to the wrong position. Now we're almost finished, but to isolate x, let's divide by negative 0.05, and then we have to divide the left side by negative 0.05. So we're taking negative 0.3 divided by negative 0.05, and that gives us 6. So we found x. Now we want to make sure we're answering the question in the problem. The question in the problem asked how many nickels. Well, x represents the number of nickels, so we just found that. We can say there are 6 nickels. The problem also asks how many dimes. So to compute how many dimes, we need to calculate 48 minus x, which would be 48 minus 6, which leaves us with 42 dimes. Okay, let's take a look at one last problem together. In this problem, we're dealing with moving vehicles. So let's read through the problem first. 2 cars leave from the same location at the same time and travel in opposite directions along a straight road. One car travels at a speed of 30 miles per hour. The other car travels at a speed of 45 miles per hour. How long will it take the 2 cars to be 255 miles apart? To start, if you're dealing with a problem involving moving vehicles, I highly recommend drawing a quick picture. This can help you to organize the information and to really visualize what's going on. So let's see, we have two cars leaving from the same location and they're traveling in opposite directions. I'm going to suppose that one car is traveling east and the other car is traveling west. You could have the cars traveling north and south if you prefer. Now let's read through the information in the problem. One car travels at a speed of 30 miles per hour. So I'm going to suppose that's car 1 traveling at 30 miles per hour. The other car travels at a speed of 45 miles per hour. So I'm going to suppose that's car 2. How long will it take the two cars to be 255 miles apart? So the two cars will start in the same location and they're going to travel in opposite directions. And we want to know at what point is their distance apart 255 miles. Let's start by introducing our variable. The question asks how long. So our variable here is going to be time. So I'm going to let t be the time the cars are traveling. Now it says that the cars leave at the same time. So we're going to assume that the cars start and stop at the same time. So both cars will be traveling the same amount of time. For problems involving moving vehicles, creating a quick chart can be a very nice way to organize your information and to help come up with your equations. So for the chart, I'm going to have two rows with car 1 and car 2. Maybe in your problem you have trains moving, so then you'd have train 1 and train 2. And then for the columns, one column will be the rate, one column will be the time, and the other column will be the distance. Now there's a very well-known distance formula. You may know it off the top of your head. The distance formula is that distance is equal to the rate times the time. Okay, so now we have our chart or our table. Now we just want to fill in the information. Let's see. Car 1, we're told, is traveling at a rate or a speed of 30 miles per hour. Car 2 is traveling at a rate of 45 miles per hour. The time, we don't know. That's what we're trying to find out, but we're letting the variable t represent the time. So we can fill in t for both cars, since both cars are traveling for the same amount of time. Now, one of the most common mistakes here is for distance, a student will put 255 here or here. In this space here, we want to know the distance traveled by car 1. In this distance, we want to put the distance traveled by car 2. 255 miles does not represent the individual distance that car 1 traveled or the individual distance that car 2 traveled. So we wouldn't put 255 here or here. 255 miles represents the distance that they are apart after they've both traveled in opposite directions. So we don't actually know the individual distance traveled by car 1 or car 2, but we can represent it using this distance formula. We know that the distance is equal to the rate times the time. So the distance for car 1 can be represented as the rate 30 times the time t. And the distance traveled by car 2 can be represented by the rate 45 times the time t. Now that we've organized our information in this table, we're going to now come up with our equation. Now let's see, what piece of information have we not yet used in the problem? We haven't yet used this 255 miles, which is the total distance that they're apart. So the general equation we can use for this problem is the total distance is equal to, if we take the distance traveled by car 1 and add the distance traveled by car 2, that will give us the total distance traveled. I'll say that one more time. If we take the distance traveled by car 1 and add that to the total distance traveled by car 2, that will give us the total distance traveled. So this is the general equation we're going to use here. So we know that the total distance traveled is 255 miles. We don't know exactly what the distance is traveled by car 1, but we can represent it using this expression 30t. And we can represent the distance that car 2 travels using this expression 45t. Now we've made it through the hard part. Now we just need to solve this equation for t. So let's combine these like terms. 30t plus 45t will give us 75t. And we can bring down the 255. Now to isolate t, let's divide by 75. And then we'll divide the other side by 75. And 255 divided by 75 gives us 3.4. So we've isolated our variable t. Let's make sure we've answered the question. How long will it take the two cars to be 255 miles apart? So t is our time, and it looks like the units here are miles per hour, so this time must be in hours. So it will take the two cars 3.4 hours to be 255 miles apart.